Okay, so let's start as it is already the time. So I'm just going to share my screen at first, and after that we will see. Can you see my screen? Okay.
Yes, sir.
Okay, fine. Okay, so today is the second class for the GATE topic, and the GATE topic for today is general aptitude. Okay, maybe I should wait for a couple of minutes, and after that we will start, so that people are coming still. So I will wait for 1 minute more, and after that we will start. Okay, so let's start. So today we will discuss about general aptitude and mathematical physics. This is the GATE topic for today's class, and today we will talk about GATE 2022 question paper. And here in that question, there will be 1 hour session, and in that session we will discuss about 2 questions. One will be from GATE general aptitude, and another will be from mathematical physics. And this is the second live session for the GATE. So let's talk about the question number 8. Like I have choose 2 questions from general aptitude and mathematical physics topic. One will be from general aptitude. At first we will talk about that one, and in the next question it will be from mathematical physics. So let's start. So the first question, in that first question, in question number 8, you can see the above frequency chart shows the frequency distribution of marks obtained by a set of students in an exam. From the data presented above, which one of the following is correct? So here you can see okay. So in that figure you can see that there is like in a y-axis it is frequency, and the x-axis it is marks. So what does this mean basically? I'm just going to write this one a little bit. You can see here that this type of bar chart bar is like, it is like a 3 number of students got 3 marks, 9 number of students got 4 marks, 11 number of students got 5 marks, similarly 7 number of students got 6 marks, and all like that. Okay. Yes. So they were asking like what will be the correct answer among these 4. So like mean greater than mode greater than median. Mean see, like in statistics we have already known that what is mean, median and mode. So they are asking that which one will be the correct combination. Mean will be greater than mode, or mode will be greater than median, or like among these 4 options one will be correct. Okay. So for that we have to know that what is mean, what is median, and what is mode, right? So like in that chart I'm just writing here a little bit, like here what is that, 3394. So I'm just going to write here 33, then 94, then again 11576, 11576, and then 2849. 7 is there, 14 7 this is 14 7 2 8 and finally 4 9. This is, let's say, 4 9. So that type of chat part is there. So that means our number of students get 3 marks. Okay. So similarly, like 9 number of students gets 4 marks. Then 11 number of student get 5 marks, like that. So at the very first, if we will want to calculate mean, then what will be the mean for that? Mean is nothing but, like, let's say here 3 number of students get 3 marks. That means as a whole how many marks will be there? 3 into 3, that means 9 marks. Similarly 9 into 4, okay. Similarly 9 into 4, then 11 into 5, then 7 into 6, and then it is 14 into 7, and then finally it is 2 into 8, and after that 4 into 9. So as a whole that many marks will be there, and it will be divided by the number of students. How many numbers of students are there? So if I want to do that one a little bit, like it will be like mean will be like 3 into 3 plus, let's say, 9 into 4 plus 11 into 5 plus, it is like 7 into 6, and then 11 into 7, and then 2 into 8, 4 into 9, 2 into 8 plus 4 into 9. So this is the total.
No.
Yes,
14 into 7.
Oh, sorry, yes, thank you. 14 into 7. So 14 into 3 into 3 plus 9 into 4 plus 11 into 5, I think I have written 7 into 6, and 14 into 7, 2 into 8, and 4 into 9. So this is the whole marks they have got. I mean, this is the whole mark got by the whole of the students. So what we will do right now, we will just divide that one by whole number of students. So how many number of students are here? The number of students are nothing but 3 plus 9 plus 11 plus 7 plus 14 plus 2 plus 4. Okay, so that means it will be 3 plus 9 plus 11 plus 7 plus 14 plus 2 plus 4. So this type of, I mean, that much number of students are present in this chat box, and we are just going to divide that one from the total marks, whatever it is. So if I calculate that one a little bit, like I think I have already calculated, but still I am just going to calculate here also. So if I okay, so I am going to calculate that one. Let's say 3 into 3, obviously 9, plus 9 into 4, 36, plus 55, plus 42, plus 14 into 7, plus then 16 plus 36. This is the whole marks. Then it should be divided by 3 plus okay, so 3 plus 9 plus 11 plus 7 plus 14 plus 2 plus 4. So it is 5.84. You can see here it is the result is 5.84. Then so what will be the mean for here? It is 5.84 for that specific example. So this is the mean. Then what about the median mode? Yes. So what will be the median? So for that median is very simple. So what we will do here is median means like which one will be the middle value. Okay. So like you can see here the marks are, yeah, do you have any question? Okay. So
yes, no, write in ascending order and take the mean of middle two values, that is the median.
Yeah, like you can see here that 3 plus 4, like it's a very simple thing. You can just simply calculate that one. 1 2 3 4 5 6 7. Okay, so 1 2 3 4, that means 1 to 7. So what is the minimum, I mean middle value for that? Like there is
4.
Yeah, 4 means like which one? 6, right? I mean it is the position, like first position, second position, third position, fourth position. Like I'm just 1 2 3 4 means it is the position, which position it is there. So the fourth position will be the median one. So fourth position means what? 6 value. So that means our median will be 6. Right? Now come to the mode. What is mode? Mode means like how many. Okay, I'm going to erase that one a little bit so that it will be clear. Yes. Okay, so what is mode? Mode means like how in which mark maximum number of students got. I mean,
Madam, there is 7 numbers, then we can say easily middle value is the median. But if there are 8 numbers, that means take the average of middle two values.
Yes. As it is 7, I mean like as a odd number, then we can simply say that okay, that middle one is the median. But yeah, if there is like let's say 8, then we can have like which one will be there, like 3 will be the third position as well as fifth position, right? So third position, so third position and fifth position we have to average that one simply. Okay, now what we will do? Okay, mode. What will be mode? Mode is like that marks at which most number, maximum number of students got. So maximum number of students got in which mark? You can see here that 14 number of students got 7 marks, right? So that means if I write the median value, mode for value for this chart, then it will be only 7 simply. Like if we will have that type of question, we will just need to calculate mean for that, and mode we can directly say by seeing the chart. Okay, and what about median? For median we are just going to calculate that, I mean 1 2 3 4 5 6 how many positions are there, and we are going to half that one simply. So for that mode value, what will be mode for here? You can see, can you tell me what will be the mode for this chart?
14.
7. No, 14 is like in which marks maximum number of students got. So yes, so maximum number means it is 14. So 14 will not be the mode, but mode will be that marks in which maximum number of students got that one. So 14 number of students got that one, and it is the maximum number in which 7 is there. So that means the mode will be 7 for that. So I am just going to write here mode is 7. Now you can see here mean is 5.84, median is 6, and mode is 7. So which one should be there? That mean is less than median and is less than mode. Now you can see that in your question it is like greater than. I mean that ascending series. Sorry, descending series. Yeah. So what will be here? It will be like mode greater than median greater than mean, right? So if I just see here, then it will be mode median mean. That means the B answer will be the correct one. Do you got the point? Like it's a very simple thing, because obviously you know that the general aptitudes are basically coming in the very front of the paper, right? Like it is only for the 1 marks, or like it is max to max 2 marks are there. But I have taken it from question number 8. That means it has, I think, 2 marks as per I understand, remember. But yeah, fine. Like it is a very simple question. So in the simple question, what you will do, you will just calculate mean value, and then by seeing the how many number of students got the maximum marks, that marks will be the mode. And for median, you are just going to calculate like how many positions are there, and you are going to half that one. So then you can have all the values, and by comparing these values, you can have the correct option. Okay. Do you have any question? You can ask me.
Ma'am, can you once please repeat the formula for this question to calculate the mean?
Okay, for calculating mean. Okay. Yes. Fine. No problem. I'm just going to erase these things. Yes. So mean is what? Mean is nothing but the total number of marks divided by number of students. Okay. So here you can see, I mean from that bar chart, what is the meaning of that bar chart? The meaning of the bar chart is nothing but like 3 number of students getting 3 marks. Each and everyone got 3 marks. Similarly, 9 number of students, each and everyone got 4 marks. 11 number of students, each and everyone got 5 marks. Like that it is coming. Okay. So as a whole, how much marks are there? See, 3 number of students, each and everyone got 3 marks. That means as a whole 9 marks. 9 number of students got, each and everyone got 4 marks. 9 into 4 marks. So as a whole, if I calculate these things, 3 into 3 plus 9 into 4 plus 11 into 5, like that, then we can get the total marks, right? That total marks should be divided by total number of students. So total number of students are what? These are the number of students, right? As I told you that 3 number of students got 3. That means 3 is a number of student. Then 9 is also a number of student. That means we have to calculate 3 plus 9 plus 11 plus 7 plus 14 plus 2 plus 4. Right? So as a whole, what we will do? As a whole, we will calculate the total marks divided by total number of students. That is nothing but mean. So for that, we have calculated here mean equals to 3 into 3 plus 9 into 4 plus 11 into 5 plus 7 into 6 plus 14 into 7 plus 2 into 8 plus 4 into 9. This is the total marks, and it should be divided by 3 plus 9 plus 11 plus 7 plus 14 plus 2 plus 4. Then we can get the actual mean value. Okay. So mean is nothing but total number of marks, total marks divided by total number of students.
Okay, ma'am. Thank you, ma'am.
Okay. And what about for mode and median? I think you all got it. So it's a very simple thing. Okay. So if it is done, then we can go to the next question. Okay. Yes. So this is the next question. So this question is coming from the math. Okay. This question is from mathematical physics. Okay, mathematical physics topic, and the question number is 13, and it is also taken from the 2022 question paper, GATE question paper. So what is there in that question? Every time I forget to do the auto. Yeah, are you telling something?
Madam, in previous question, while calculating mean, if we multiplying both the students and marks, even though we are dividing by number of students, no?
Yes.
That means mean is the average, no? Sum by total.
Yes, total. This is the sum for the whole marks, and then this is the divided by total number of students. How many number of students are there? So as a whole, this is the division. So as a whole, we can get a number which is 5.84, and the mean we have calculated as 7, and mode also we have calculated as 7. Sorry, median is 6 and mode is 7. So we can compare these things, and we can get the correct answer that mode is greater than median is greater than mean, like that. Okay, so coming to the next question. In the next question, this is coming from the mathematical physics topic. Okay, as I told you that the first question will be from general aptitude and the second one will be from mathematical physics. So what is the question here? The question is question number 13. What is the maximum number of free independent real parameters specifying an n-dimensional orthogonal matrix? And the options are 4 options are there: n into n minus 2, n minus 1 whole square, n into n minus 1 by 2, n into n plus 1 by 2. There are 4 options are there. So what will be the answer for that? To answer the question, I just want to tell you one. First of all, I will give a detailed explanation, and after that I will tell you a trick. Okay. So let's say I'm just talking about, they are telling about this is the maximum number of free independent real parameters specifying an n-dimensional orthogonal matrix, right? Just focus on this one. It is an orthogonal matrix. So what is the condition for orthogonal matrix? Do you know that? If let's say I am having one matrix which is A. So what is the condition that this matrix should be a orthogonal? Sorry?
A inverse will be equal to A transpose.
A inverse will be equal to A transpose. Yes, good. Like, okay. Yes. Actually, As a very first, when we are talking about any orthogonal matrix, it is nothing but, let's say I am having a orthogonal matrix, then obviously A transpose A will be I, as you already told that A transpose will be A inverse. Like A inverse means I by A will be there, then it will be A inverse. So this is the condition for the orthogonal matrix, right? So A transpose into A should be I. As in that question it is already mentioned that what type of matrix you are talking, that will be a orthogonal matrix. So this matrix, whatever A will be, it should follow that type of equation. Fine. Okay, so that this is the main motto of our question. So this is the first clue we can get from that question, that A transpose into A should be equal to an unit identity matrix, which is I. Now coming to okay, now that is the first clue that I am talking about orthogonal matrix. And what is next? They are asking that what is the maximum number of free independent real parameters. So what is meaning of the free independent real parameters? First of all, real parameters means it should not be an imaginary. Fine. Independent real parameters means what? Independent means, let's say I am talking about, I don't know that you all people know that independent and dependent variables or what, so I am just going to tell a little bit about that. Let's say I am having A, B, C, these three variables. Okay, they are okay. There are three variables A, B and C. Let's say I am assuming three variables. Now I am having one condition. Let's say A plus 2B equals to 0 and let's say A plus 3C equals to 1. These two conditions I have, right? So I have three parameters here, three variables A, B and C, and I have two conditions here. So what is the meaning of this condition? In that condition you can have a relation that A equals to minus 2B. And from this relation also I can have one condition that A equals to 1 minus 3C. Then I can also write here minus 2B will be 1 minus 3C. Right? Then you can see that minus 2B plus 3C will be 1. And I can have another condition from this one. So let's say I don't know about A, B and C. Fine, no problem. But by any chance, if I can get B value, let's say I know the B value, then obviously immediately I can get the C value from this equation, right? Good. And if I know the C value from here, then obviously I can get immediately A value from this equation. So what does this mean? Previously I did not have any idea about A, B, C. These were three variables. But also I had two equations. So from the two equations, our free independent number of parameters reduces to 1. Previously, if I did not have these two expressions, then to me it was three free real independent variable. Okay. So previously if A, B, C were there and no equation like A plus 2B equals to 0 or A plus 3C equals to 1, that type of equation was not there. That means I have only A, B, C and that three variables should be free independent variables. But as I already have these two expressions, that means we are reducing the free independent variable to 1. Now after imposing these conditions, I can tell you that if by anyhow I can get the B value, I can definitely tell what will be the value for C, what will be the value for A. Do you got my point? So that means if we have one condition for any type of free parameter, any type of list of free parameters, then we can get some dependency on that free variables and we can reduce the independency from that dependency. Okay, so what they are asking that how many free independent real parameters will be there. So from this example you can see that previously there were 3 independent variables, but after imposing these 2 conditions I got only 1 free independent variable, right? So whenever they are asking about free independent variables, we need to search some conditions like that, so that we can reduce our independent variable to dependent variable, and which one will be left, that will be the answer. Is it clear to everyone? Yes?
Yes.
Okay. So now, yeah, good. So there are 2 main things in that question. One is orthogonal matrix and another one is free independent real parameters. So by the help of orthogonal matrix condition, by the help of this condition, I will make some type of expressions so that our whole number of independent solution can reduce to some dependent solution, and we are going to just subtract the dependent solution so that I can get the actual number of free independent solutions, free independent variables. That is the main motto. So there are 2 things. Fine. Okay. Now for the very first case I am going to calculate one 2 by 2 matrix, because one 2 by 2 matrix, if I understand correctly, then we can go for the n value, because like 2 by 2 means it is a very simplest matrix, and if we can get the free independent variable for the orthogonal 2 by 2 matrix, then we can have an idea that what will be the value for the general matrix, right? So let's say I am writing here one 2 by 2 matrix. This is 2 by 2 matrix. So first of all, whatever I am right now telling, that is the total detailed calculation, right? But in your exam you don't need to calculate all these things. You will just calculate whatever is needed specifically. Okay. So this is a 2 by 2 matrix. Let's say I am writing. So 2 by 2 matrix means like I am just taking as a random value A, B, C, D. So in that calculation, if I am not doing anything, then you can see that A, B, C, D, there are 4 independent variables. But after that, if I want to impose some conditions on that, then obviously you can see I am putting some relations like that, so that you can have some dependency and you will see how many independent variables will be left. Okay. Now okay, so what is the condition for orthogonal matrix? As I told you that orthogonal means A transpose A will be I. Fine. Now I am just going to calculate A transpose A at the very first. So you can see that for 2 by 2 matrix you can obviously calculate A transpose A. There is no problem, right? So A transpose A means A, B, C, D transpose, then A, B, C, D. And what will be I? I is 1, 0, 0, 1, because it is a 2 by 2 matrix. Good. Now if I going to transpose that one, what will be the value? A, C, B, D. As I think all of you know that what is the transpose of a matrix. Then A, B, C, D, which is nothing but 1, 0, 0, 1. Good. Now coming to the next part. What is next one? You can just simply multiply that one. Let's say it is A square plus C square. Then what will be this one? AB plus CD. CD. Yes. Now this is AB plus again CD, and this is okay, B square plus D square. You can tell me if I am going into first, or I am getting wrong answer or whatever. You can tell me, no problem. So by that multiplication you can see that I have a matrix in the left hand side and I have a matrix in right hand side. What is the matrix in right hand side? It is nothing but the unitary identity matrix 1, 0, 0, 1. And what about in left hand side? In left hand side you can have 2 by 2 matrix, and each and every element are non-zero. Then we can have a condition from that. Obviously, what will be the condition for that? A square plus C square will be 1. AB plus CD will be 0. You can see here that this one will be 1. this column should be 0 value. That means AB plus CD should be 0. And also you can see that AB plus CD is also 0 here. That means we don't need to do anything because the same expression is coming. And the next one is B square plus D square will be 1. So there are 3 conditions. I told you that previously, just like this expression, I can get here 3 expressions. A square plus B square equals to 1, AB plus CD equals to 0, B square plus D square equals to 1. Now can you tell me, like from here, A square equals to 1 minus C square as per I can see, right? And from here B square will be 1 minus D square. And here from that I can see AB equals to minus CD. Now can you please tell me, previously it was A, B, C, D all were free independent variables. From these 3 conditions, okay. From these 3 conditions, we can obviously reduce the number of free independent variables. Now, what will be the free independent variable right now? Can you tell anyone? Like, I have 3 expressions, and from that 3 expression, how many number of dependency I can get, so that I can have, let's say, x number of independent variables. So, what will be the value of x here?
2.
2. Okay. So that means you are talking that I can get 2 independent variables from these 3 conditions, and previously, okay, just a minute, and previously it was 4 because we can have previously A, B, C, D. But right now, after imposing these 3 conditions, you are telling me that there will be 2 independent variables. Let me check at first how many independent variables will be. Okay, first of all, A equals to 1 minus C square. That means by anyhow, if I can get the knowledge of C, I can get A. That is correct. Okay. From this, you can see B square equals to 1 minus D square. So, by any chance, if I can get the value of D, I can obviously say what is B. Now you can see here AB equals to minus CD. Then okay, so can I write A, B in terms of C and D? Obviously, because 1 minus root over 1 minus C square into root over 1 minus D square, right? So root over 1 minus C square, root over 1 minus D square will be minus CD. I can also get that type of expression, right? So from this expression, if by any chance I can have the knowledge of C, I can obviously calculate D value, isn't it? Right? So you can see that B has a dependency on D, C has a dependency on A, or reversely also we can tell C also has a dependency on D. Then how many number of free parameters we are getting? Only 1. Because if I can know, let's say, D value, then I can have C value. If I can have C value, then I can have A value. And also A and and as I am getting D value, so I can also get B value. Then I can get all the values, right? So from these 3 expressions, I can get 3 number of parameter and 1 will be independent here. Is it understandable, or should I tell again? See, if you understand 2 by 2 matrix, then we can generalize it very simply. Should I explain again? Can anyone tell me? Or it is fine?
Yeah, it's fine, ma'am.
Okay, so that means what is the meaning of that? If I am taking about 2 by 2 matrix, in the 2 by 2 matrix previously 4 independent variables were there, and by imposing that orthogonal matrix condition, I get 3 equation, and from 3 equation I can get one condition that okay, just a minute please. Yeah, from that 3 expression I can get three values of free independent parameters by only having one independent one independent variable. So as a whole, by imposing these set of expressions, I am just going to reduce the free independent parameter number. So now for 2 by 2 matrix, in that question, whatever is that, if it is a orthogonal matrix, then I can have only one free independent parameter. Okay, so I can have one answer that if it is a 2 by 2 matrix, then if it is an orthogonal matrix, I can get only one free independent parameter. So now coming to general form, from 2 by 2 I can get 1, that is fine. Now coming to general equation, let's say I am having n by n matrix, because I think they have already mentioned about n by n, yes, n dimensional orthogonal matrix. So if I am having n by n matrix, then what will be the free independent variables? And okay, so what will happen here? How did I get these three expressions? Can you tell me how did I get these three expressions? These three expressions I get only from a dagger a equals to I, that equation. Okay, so let's say I have n by n matrix. So if I am having n by n matrix, then how many free parameters are there? For 2 by 2 matrix, I was having 4 independent parameters previously, like before imposing these conditions. So before imposing the conditions, I had 4 independent parameters. So similarly, for n by n matrix, how many independent parameter will be there before imposing any type of condition? How many number of free parameter will be there? N
square.
N square. Good. So just similarly, 2 into 2, 2 into 2 is what? 4. So similarly, n into n, that means n square. N square is nothing but n into n. So n square number of free independent parameter I get without imposing any type of condition. Now I am going to impose some condition that let me write here. This is A. So what is the condition? The condition is a dagger A will be I, and a dagger A will be in n by n matrix, and I will be also in n by n matrix, because you know that if there are two matrices of n by n, then the matrix multiplication shows that the result will be also in n by n, right? And obviously if the left hand side is n by n, the right hand side should be in n by n matrix, and it will be an identity matrix. Okay, now let me tell you one thing. So whatever will be the answer, that will be n square free number of free independent variable were there previously. Now I am going to impose this condition. In that condition, you can see that whatever will be the result by A transpose A, there will be some non-zero values in each and every point. I mean, these are like 1 term, 1 2 term, 1 3 term. In each and every term, there will be some non-zero terms, right? And in that right hand side, what is there? There will be 1 0 0 0 like that, then 1 like that, then 1 like that. I mean, only in the right hand side, only in the diagonal term there will be 1, and in that off diagonal term there will be 0. Okay, and in that left hand side, where are there? They are basically in the non-zero terms. So what will be the condition from that? You can see here, from this 1 1 term, this can be equal to 1, this can be equal to 1, this can be equal to 1. That means each and every diagonal term, whatever present in that A dagger A transpose A formula, then these terms should be equal to 1, and rest of the things should be equals to 0. Then how many number of equations I can get? That is a main question. So how many number of equation I can get?
N plus n into n minus 1 by 2.
Yeah, like you have answered so quickly, but yeah, let me explain a little bit. Like obviously you can know all these things, but rest of the people don't know maybe. So yes, so as he already told that there is A dagger A and here I. So at the very previously it was n square number of free parameters. Now I am just going to impose the conditions. So how many conditions will be there in each and every diagonal? That means how many diagonal will be there? It is a n by n. So how many diagonal will be there? N. Okay. So in n number of diagonal equations, that should be equal to 1, because in each and every diagonal term the value will be 1. So we got n number of equations which are like in the left hand side something is there and in the right hand side there will be one value. Okay. So n number of equations I get at the very first. Now you can see here there are all the non-diagonal terms are there. Then how many numbers of non-diagonal terms are there? Obviously n square minus n, because I have a I have subtracted n from n square. So n square minus n are number of diagonal terms. But also you can see that if I am telling here, yes, this is a off diagonal, this is also off diagonal. So from these two you can see that this off diagonal and this off diagonal are nothing but same. That means we have to calculate like n square minus n by 2. These all different equations has a left hand side something non-zero and right hand side will be 0. Why it is divided by 2? Because it is a nothing but a symmetric matrix. Something transpose something will be I, that means it should be a symmetric matrix. So you can see from this condition n number of equations are in the left hand side something non-zero and in right hand side there will be 1, and the rest of the things, that means n square minus n square minus n by 2, that type of term in the left hand side is giving the right hand side is 0 value. So how many number of equations we are getting? We are getting that type of equation. We are getting n square minus n minus n square minus n divided by 2, because this n is giving us right hand side as 1, this term is giving us right hand side as 0. So as a whole, how many differential equation we can have? N plus n square minus n by 2, that much differential equation I can get. So obviously how many free parameters will be there? N square minus this one. So if I write a little bit calculation on that, then you can see n square minus 2n. Okay, directly I can write here 2, then 2n square minus 2n minus n square plus n. Then you can have, sorry?
Ma'am, how did you take that last step? I couldn't get it.
Okay, fine. Just a minute. Actually, I am going to write that one. Okay. See, we are just going to taking some analogy from that 2 by 2 matrix. In that 2 by 2 matrix, you can see that previously we had 4 independent parameters and I got 3 differential equations, so that I have 4 minus 3, that means 1 free parameter. Is it clear? For 2 by 2 only, right? Yes. Yes. So in 2 by 2, what we did like how many number of free parameters were there, and we are going to subtract that one, that how many differential equation we can get from that condition. So we can get 3 differential equation from that condition that it is orthogonal. So we are just doing 4 minus 3, which is nothing but 1. Similarly, for n by n matrix, what we will do? In n by n matrix, previously n square number of terms were there. Wait, I'm just going to clear a little bit so that it will be understandable. Okay, so now in that n by n matrix I have A transpose A will be I, and each and every term is n by n matrix. So that means, let's say in the left hand side I am having something this like that. I mean, these are like nothing but the terms, right? This is n by n matrix. And in the right hand side, what I will have like that, 1, then like that. Only in diagonal term I can have 1 value, in the off diagonal all terms I can have 0 value. Is it clear? Yeah.
Yes, ma'am.
Yes. So you can see here that previously I had, in that left hand side I have n square number of terms, and these are all non-zero. Now I am going to calculate how many differential equation I can get. If I am getting, let's say, x number of differential equation, then obviously the number of free parameter will be n square minus x. Fine. Then our main motto is to find how many dependent equation I can get. So how many dependent equation I can get? You can see in that n by n matrix there will be n number of diagonal terms, right? Because in the 2 by 2 matrix obviously there were 2 number of diagonal terms. So similarly in n by n matrix n number of diagonal terms should be there. So if it is n number of diagonal terms, each and every number diagonal term should have a equation that something whatever it is there is equal to 1. Something whatever it is equal there, it is equal to 1. Similarly up to n value, whatever it is there, it is equal to at the very last 1, whatever it was 1, right? So that means we can get n number of dependent equation from these diagonal terms. Is it clear?
Yes, ma'am.
Yes. Okay. So first of all I can get n number of differential equation. Okay, fine, from that diagonal one. Now coming to non-diagonal one. What about off diagonal one? In that off diagonal one you can see there are so many number of terms, and whatever will be the value, it should be 0, because in all the off diagonal terms the right hand side is 0. Now we have to calculate how many number of off diagonal terms are there. Obviously number of off diagonal terms is n square minus n, right? But the main problem is this is a symmetric matrix. If it is a symmetric matrix, then whatever it is there in that region, that is exactly equal to this region. So let's say n square minus n divided by 2 is here. That much number of equation I can get from this portion. Exactly n square minus n divided by 2, that much number of equation I can get from this portion. And these two portions are exactly equal. That means our number of differential equation will be n square minus n divided by 2, which are coming from off diagonal terms. Okay. So n square minus n was all the off diagonal terms number. As it is a symmetric matrix, we are going to divide it by 2, and we are going to calculate all the term to equal to 0, because all the off diagonal terms are 0 here in the right hand side. So that's why n square minus n divided by 2, this is coming from off diagonal term. Off diagonal. This is coming from diagonal term. So that many number of diagonal terms is there for the differential equation calculation. That many number of differential equation will come from off diagonal terms. Do you understand?
Yes, ma'am. Yes.
Okay. So now obviously in one matrix only diagonal terms are there and off diagonal terms are there. There are no other terms. So obviously we can get all the differential equation, all the number of differential equation is nothing but n plus n square minus n divided by 2. This is the total number of differential equation we can get. Then now we have to calculate how many free parameters are there. Free parameters are nothing but n square minus this term. So if I calculate this one a little bit, I think I have already calculated, but still I am going to calculate again. Okay. Yeah. So n square minus, you can see here I have written n plus n square minus n by 2. So these whole are like number of differential equations I can get from that condition A transpose A equals to I. Now I am going to calculate this one. Then you can see here, if I calculate 2n square minus 2n minus n square plus n. Then if I just going to solve a little bit, then what will be the value for this one? The value will be like, yeah, it is coming here. So 2, then 2n square minus n square, 2n minus 2n plus n minus n. So which is nothing but n into n minus 1 by 2. So that many number of free parameters should be there in an orthogonal matrix.
Ma'am, my confusion was here. One doubt was there. How can we know that after subtracting these number of equations?
Yes. Okay.
N square, that is the total number of independent elements. You are subtracting the number of equations from the total number of elements.
Yes.
Why are you doing that? And how did we know that by doing this we can get the real parameters?
Simply you can see here that we had previously 4 number of independent variables. Now we are taking, I'm just having that much number of equations from this orthogonal condition. So how many number of orthogonal condition, how many number of equations I can get from the orthogonal condition? I am getting 3 equations from that orthogonal condition. So you can see that as also we get the one answer as 1, because you can see that a square equals to 1 minus c square, b square equals to 1 minus d square, ab equals to minus cd. So these 3 conditions obviously giving us only one free independent variable. If it is a, then from that value of a I can get rest of all the things b, c and d. So that means what? That means like the free independent is nothing but 4 minus 3. And what is 4? 4 was n square. What is 3? 3 is n plus n square minus n by 2. Like you can give an analogy with that 2 by 2 matrix to the n by n matrix. And also you can see that as it is a symmetric matrix, obviously it should be done for each and every dimensional matrix. Like if it is a 3 by 3 or if it is a 4 by 4, you can also try. That is obviously it should be done always. That whatever the number of equations we are getting from that condition. Okay. Someone is joining right now. Okay. So whatever will be the answer, whatever will be the differential equation, if I do the subtraction from that to the total number of parameters, then we can get the free number of parameters. Because 3 equation means we are getting 3 dependency and we are having 4 free parameter. So obviously one free parameter will be there as a whole, right?
Yes, ma'am, got it. Thank you so much, ma'am.
Okay. So this is the thing. So like what I did actually in your exam, let's say I'm just having this question in your exam. So we don't need to do the 2 by 2 calculation and all these things. What we will do, we will just do the n by n directly. And in n by n obviously we have to remember 2 things, that in orthogonal matrix what is going to happen. A transpose A will be I. This is the first condition. And the second condition is free independent means like you have to subtract all the dependency to the total number of parameters. So these 2 we have to remember in your mind. So for that we will not calculate 2 by 2 in the question. Okay, something is there in the chat. Don't take much explanation of single question that times. Yeah, actually that is correct, but the main thing is that like in that 1 hour session we will discuss 2 questions, and these 2 questions they were asking me to explain very well so that each and every student can get that one. Like obviously like whoever have written that one he or she will understand that one very quickly, but like maybe someone does not understand that one very quickly, so that's why I am just going to explain. But yeah, like you can see that I have already explained 2 questions, and in that 2 questions only I am just going to explain today. So if you have some doubt on that, you can ask me anytime, or you can if you have some more doubt on any type of topic, you can ask me also. But yeah, like I mean, whatever we are talking about, these 2 questions should be understood clearly. That is the main motto. Okay, so that's why we are taking that much explanation and all. Okay, so I think you people have understood this one, and I did not have any question right now in my hand today. So in each and every week we are going to calculate, we are going to solve in detail 2 questions per week. Okay, so 2 questions per week, and this is the first question in that week I have taken, and this is the second question, and these 2 are from 2022 question paper. That is the thing. So if you have some question, if you have some doubt on these 2 questions, you can ask me, or you can ask any type of doubt if you want to comment or discuss with me, because we have already going to end the session, but still we have 5 more minutes. Ma'am, we'll take more questions. Will learn only few topics. Yeah, that is the thing. So like basically what the NPTEL coordinator told to us, like you have to understand whatever you are going to understand very clearly, I mean, like there will be no problem on that. That is the thing. But obviously 2 questions is a very small in number per week, that I understand. But you can see in that GATE portal there are different topics in different week also, because like not only me, there are so many teachers like me, he or she is going to explain these GATE questions, so you can also attend their questions. And also if you want if you want that I am going to tell more questions, then I can think about more questions on that also. That is also possible. But they told us to explain in 1 hour how much you can do. So in how much means they have taken us as 2 questions minimum, and after that you can also add in your choice. So if I can see from the next class that I can explain 2 questions very clearly, and each and everyone should understand that one very clearly within, let's say, 45 or 40 minutes, then I can add 1 or 2 questions more. Do you understand? So like that we are doing. And also don't worry, there are so many topics, and each and every topic of physics are going to cover by there are so many teachers. Okay, so like each and every week there are let's say each and every day I think there are live sessions, like 1 hour live session. So by that you can also cover whole the topics of physics. Yeah, how can I contact for doubt? Can you join this WhatsApp group? Can I join this WhatsApp group? Okay, I don't know I can join in that or not, but yeah, I can tell you one thing. I can give you my email ID so that yes, this is my email ID. If you have any doubt, then you can ask me. I mean, like obviously you can ask me anytime during the class. That is one thing. And next to that class also, if you have some doubt, you can ask me in that mail also. Like whenever I will be free, I will obviously try to solve these questions if you have some doubt on any type of topic. Okay. How can we will get the formula sheets? Formula sheets, how can we will get formula sheets of what? Like in each and every topic you are talking, or whatever I am telling today, that formula you are talking? Because in that class there is no that much important formula. This is just a, what should I say, this is just a presence of mind or something. But if you want that formula means like whole the topic formula, I think it is obviously in any type for whole single subject wise. Whole single subject wise. Yeah, like physics, right? You are talking about total physics formula and all. So yeah, that I will prefer that you have to make by yourself. That will be very good for you, because when once you are going to make a chart of all the, can we, this PPT PDF, I mean, can you have the PPT? Okay, yeah, just a minute, I'm just going to answer the question of KGF. Yeah, I'm just going to answer the question of KGF. See, basically if you are going to know the whole formula list, it's better to make by yourself. That will be very much impactful for you. Okay, so like whenever you are going to answer some questions, you are obviously you have to write some formula, and whenever you are going to practice your own by your own, then you are getting some problem in that formula, then obviously you are going to write that formula in your notebook. And and not only notebook, you can make a sheet of that total list of all the formulas and all, so that you can make by yourself as well as you can remember that one easily. So what you will do, like as per my suggestion, what you will do, you will just make a sheet, long sheet, and in that long sheet you will just write all the formula whatever you were facing during the exam, I mean test exams and all. Just write all the formulas there, and you are going to put that on your like wall or whatever, like where you are going to study, or at that place you are just going to paste on it, so that each and every time whenever you will enter the room, then you can see these formulas and you can remember easily. Okay, but don't it can also be possible that you are just going to download from internet and all these things, all the formulas. It is also possible. Yeah, it is also possible, but it's better to make by your own. Okay, yeah. Now Dakshata, yeah, can we get the PPT? Yeah, obviously, like the PPT for now at least, they did not tell us to share the PPTs. I mean that NPTEL coordinator did not ask to send the PPTs, but if you want, then I can tell to them, so that I can make a Google Drive, and in that Google Drive I can put that slides, and I think they will give the access to all of you, so that you can see these PPTs. Okay, next week yes.
That method which you told for getting the number of real parameters.
Oh yes, okay.
So that method works in all types of matrices. Like if we have to find for the Hermitian matrices, then we have to subtract the number of imposition equations from total number of elements. That method works in all types of matrices.
Yes, it will be for all types of matrices, but there is one difference is there. See here, orthogonal matrix means, I told you that this should be a symmetric matrix. So symmetric means what? This off diagonal matrix should be divided by 2, right? But for Hermitian matrix, it should not be there. You understand? Like symmetric means yes.
I was telling only we have to find the total number of impositions.
Oh yes, yes.
And then subtract them from the total number of elements.
Yes, the total number of elements minus total number of differential equation, what we are getting from that condition. That is the main thing. But we have to find that how many differential equations we are getting from that matrix. That is the main thing. Okay. That may be differ on matrix to matrix. Right? If it is an orthogonal matrix, the number of differential equation may be different. If it is a Hermitian matrix, the number of differential equation may be different. Something like that. Okay,
ma'am. And the method will be the same, like subtract the number of impositions from total number of elements.
Yes, the method is same for every matrix, but we have to consider which matrix it is.
Okay, ma'am. Okay, got it.
Yeah, and that next week कौन से topic से questions होंगे? Okay, I think next, as far I remember, quantum mechanics. I think quantum mechanics. Okay, quantum mechanics से question होगा next week. ठीक है? Yes, quantum. Quantum. Yes, quantum. Okay, so is there any question, or should we stop the session for today? I think there is no question in the chat box also, and if you have some questions you can unmute yourself also, that is also fine. Okay, I think there is no such questions, then we can stop for today's session, and we will meet in the next class. Okay, and yeah, about that drive and PPTs, sending the PPTs and all, I will talk to them, and if they will give me the permission to share this in a Google Drive or somewhere, then I can share it with all of you. Like, I think they will give the access for these things and all, then you can get to know. Okay. Okay, then bye bye.
Thank you, ma'am.
Yeah. Good night. Good night. Bye bye. Can you please show the last two slides? Oh.